In a recent lesson, you learned the formula that is used to find the slope of a line when you're given 2 points. Here was that formula. M equals y2 minus y1 divided by x2 minus x1. This was the formula that we used to find the slope of a line. However, it is important to note that the slope is also used to classify different types of lines. The first type of line that I want to identify is called parallel lines. Parallel lines. Parallel lines are lines that run side by side but never touch. They will never ever intersect. They will always have the same slope. So they have same slope and never intersect. No matter how far north, south, east, west these lines will run, they will never cross paths. All right, here's the second type of lines, perpendicular lines. Perpendicular lines. And if I'm moving too quickly, this is also spelled out for you in lesson number 7 of your workbook. Perpendicular lines are two lines that intersect to specifically form a 90-degree angle. So they don't just intersect, they form a 90-degree angle. And although my lines may seem to be slanted, I'm going to draw our 90-degree angle box here. I'm horrible at drawing, but I drew the boxes to indicate these are right angles, which means these are perpendicular lines. Perpendicular lines are two lines that intersect to specifically form a 90-degree angle. Perpendicular lines, or slopes that form perpendicular lines, are what is known as negative reciprocals. Negative reciprocals. Here's what that means. That means if one slope is 5, for it to be the negative reciprocal, we have to change the sign. So instead of positive, it now becomes negative. And you have to flip it. You have to find the reciprocal. So instead of 5, when you flip it, it becomes 1/5. So these two slopes are slopes that are perpendicular of one another. Let's try it again. If I gave you the slope, m equals -3/2. If I wanted the slope that was perpendicular to this line, change the sign. So instead of negative, it now becomes positive. And instead of 3/2, it becomes 2/3. So now we have two slopes that would represent the slope of perpendicular lines. The third type of lines that we must identify are those lines that are neither parallel, and also they're not perpendicular. They just intersect. They don't form a 90-degree angle. They're not parallel, so they touch. They're just neither. All right, so this can be one slope could be 1/2, and the other slope could be 5. There is no relationship between those two slopes. Let's say I gave you some equations. And you had to identify the type of line. For example, y equals 5x plus 4 and y equals 5x minus 1. If you look at these two equations, you notice the slope is 5 and the y-intercept is 4. Now, if you're trying to figure out how do I know which one is the slope and which one is the y-intercept, I remember because I learned the equation y equals mx plus b. Remember, this is the equation for slope-intercept form of a line. The m in this form is always your slope. The b is always your y-intercept. So m equals slope, b equals y-intercept. Oh, excuse me, not y equals, y-intercept. All right, so if you notice, the slopes are the same. So if the slopes are the same, that would make these parallel lines. They're specifically parallel because the slopes are the same. What if I gave you y equals negative 1 over 2x plus 7 and y equals 2x plus 3? All you do is look at the slopes. They're not the same, so I know they're not parallel. However, I notice one is negative, the other is positive, and they're reciprocals of one another, which means this has to be an example of perpendicular lines. They have to be an example of perpendicular lines.